Greetings everyone, you are welcome to this video tutorial. In this video tutorial, we will talk about queues in C++ and especially queue as a linked list. Linked list implementation of queue uses a linked list to store data and a pointer front pointing to the beginning of the queue and a pointer rear pointing to the end of the queue. So if we look at the memory diagram, you can see here, this is an example of a linked list and this is queue as a linked list in which we can do all the insertions at the beginning of the linked list or all the insertions at the end, at the rear end of the linked list, and all the deletions can be done from the front end. Now linked list, as you can see here, is a collection of nodes and each node has two parts, data part and the link part. And we create node with the help of self-referential structure. The data part stores the data and the link part stores the address of the next node in the linked list. Now front contains the address of first node, the very first node in the queue, and rear contains the address of last node. And each node contains the address of next node. You can see that this is the first node. The link part of this node contains the address of second node. The link part of second node contains the address of third node and so on. And in the link of last node, null is stored, which indicates that this is the end of the linked list. Now let us do a C++ program to implement operations on queue as a linked list. Now here we have included two header files, iostream.h and conio.h. Now this is a structure node in which there are two parts, the data part and the link part. The data part we are declaring a integer variable data, and in the link part we are declaring a pointer which is of type node itself. You can see the name of the structure is node and the name of the pointer is also node, which indicates that this structure is a self-referential structure. Now we are creating a class queue in which I am declaring two pointers, rear and front, of type node itself. And because they are of type node, because they are going to store an address of node data type. That is why their type is node. In the public section, we are creating a constructor queue in which both rear and front are initialized to null. And then there are three functions: insert, queue delete, and queue display to perform insertion, deletion, and display operation on the queue. Now let us see all the functions. For queue insert, we will first create a temporary node using the statements node start temp. Temp is equal to new node. In this, it is an operator which creates a memory of type which is given here after new, and here we have given memory of type node. So it will create memory of this type and return the starting address of this memory to the variable temp. So after that we will input now the memory has been created. Now we will input data in this memory. We will input, there are two things which we have to input, data, and we have to store the address of some link here. So we will simply input the data in this node, and then since every node whatever node we insert in the queue is going to be the last node, so next part will always contain null. For the newly created node, the next part will always contain null. Now we will check where to and how to make the connections for inserting this node. Now if rear is equal to null, if rear is null, this indicates that there is no node in the queue and queue is empty. So insertion of this node will make it the first node in the queue, and in this case both rear and front will point to this node. They will contain the address of this node which is stored in temp. Otherwise, if the queue is already there, if there are some nodes already in the queue, then in that case, the next of rear will contain the address of new node, and rear will now contain the address of new node, which is the last node of the queue. Then for deleting, we will check if front is not equal to null, because if front is null, it means the queue is empty. You can see here else queue empty. So in the empty queue, we cannot delete any node. So if front is not null, then we will store the address stored in front to some temporary pointer variable, which is of type node itself. then first we will display the data which we are going to delete. This is not a mandatory step. This is optional. Now we will check if front is equal to rear. If front is rear, it indicates that there is only one node in the queue, and deletion of this node will make the queue empty. So if front is equal to rear, then we will make rear equal to null and front equal to null. And if this is not the case, there are many nodes in the queue, then in that case, we will simply store the address of next node in the front. So the front will start pointing to the next node. Then at the end, we will delete temp, which was the address of the address of first node was stored in the temp. Now we will delete it, and I have already told you that if we create a node using new operator, if we do the memory allocation using new operator, it is very important to delete it using the delete operator, to deallocate the memory using the delete operator. Now to display the queue, I am storing the address of address stored in front variable to another temporary pointer variable temp, and I will run the loop. While temp not equal to null, we will simply display the data which is present at this address, and then we will simply point temp to the next node using the statement like this: temp is equal to temp arrow next. So this will store the address of next node in the temp. So next time it will display the data stored in the next node. Now we will create main. In main, we will create an object of class Q, and this is a temporary variable. So we will display a menu: I for insert, D for delete, and S for display, and Q for quit, and ask the user to input the choice. And depending upon the choice, if it is I, we will call the function Q insert. If it is D, we will call the function Q delete, and if it is S, we will call the function Q display. And this loop will work until the choice we enter is Q. Now this is the program. Now let us understand the memory representation and details of this program to make it more clear. Now let us understand the various parts of the program again. In the program, we have first created a structure, and the name of the structure is node. And this is a special type of structure. This is a self-referential structure, and it is special because it contains the pointer. It contains a pointer type variable which is of the structure type itself. You can see here the type of the structure is node, and the type of the pointer is also node. We can say that they are special structure which contains pointers to themselves. And you can have any type of data here. I have declared only integer type of data. You can have more data also here. And this type of structures are used to create linked list. The next portion of the program is class Q, in which we have created two pointers, rear and front. Front points to the beginning of the queue, and rear points to the end of the queue. All the additions take place from the rear end, and all the deletions take place from the front end. Then in the public section, we are creating a constructor, and we are initializing both front and rear by null, because this is the initial values of a pointer. Then we are declaring three functions: Q insert, Q delete, and Q display. Now let us understand this function in more detail. In the Q insert function, in the beginning we are creating a pointer of type node. This is the pointer temp, which is of type node. Then new is a operator. It is an operator which allocates a memory of the type given after it. Here the type is node, so it will create a memory of type node and returns the beginning address of this memory, which will be stored in temp. Now cout data, we have to input, we will displaying that you have to enter the data now. We will input data using the statement like this, and then we are storing null in the next, because whatever node we add to the queue is always added as the last node. So automatically the next portion will contain the null. Now if rear is equal to null, it indicates that queue is empty, and in this case this is the first node, and both rear and front, they become equal to temp. They will point to this node. Otherwise, we will simply store the address of newly created node in the next of rear, and we will make rear point to new node by assigning the address stored in temp to rear. Let us see the illustrations of it. See, in the beginning, both front and rear are null. You can see. Now we are creating a node using the statements node start temp, temp is equal to new node. So there you can see here, this is a new node which is created using this statement. And when we say scene temp arrow data, some data we can input the data. Suppose I have inputted 1, so 1 will be stored here. And when I say temp arrow next equal to null, so null will be stored in the next part of it. And the address of this node is suppose 100, which is stored in temp. Now we are checking is rear equal to null, because if rear is null, then this is going to be the first node and Q is empty. So in the beginning you can see the rear is null, so our answer is true. So we will make both front and rear point to this newly created node. So you can see here front and rear both contain 100. So only this step will be performed and this step will not be performed. Out of these two, only one will be performed depending upon this condition. Now you can see front and rear both are 100, and now I am creating one more node. Suppose this is the node which is created and I am storing the data 2 in it, and again it is going to be the last node, so I am storing null in the next portion of it, and the address of it is 200, which is stored in temp. Now rear is not null, so it will perform these two statements will be executed. Now you can understand, see it is written here rear arrow next is equal to temp. So my rear currently is 100, and in the rear of next I am storing the address which is stored in temp. The address stored in temp is 200, so 200 will be stored here. So you can see here this is my node, first node, and it contains 1 and it contains 200, which is the address of the new node. This is my new node. The next step is rear equal to temp. So rear was earlier containing 100. So when I say rear equal to temp, rear will also contain 200. My front will remain unchanged, and now rear is containing 200. Rear is pointing to the new node and front is pointing to the first node. Now let us suppose we do one more insertion. So now you can see front is 100 and rear is 200. So when I will create one more node using these two statements. So my one more node will be created, and suppose I store 3 in it, and in the next part again I am storing null because this is going to be the last node now, and suppose the address of this node is 300. So I'll check the condition. Now the rear is not null, rear is 200. So these two steps will be executed. Now again rear arrow next. Now this is my rear currently. So rear in the next of rear at present null is stored. So when I say rear arrow next equal to temp, so it will contain the address stored in temp. The address stored in temp is 300, as you can see. So 300 will be stored here. See, you can see the change here. 300 will be stored here. And when I say rear equal to temp, so now rear will also contain 300 and it will start pointing to this new node. Instead of the node having the address 200, now rear will point to the node which has the address 300. So you can see this is my newly added node is added to the end of the linked list, Q as a linked list. And at present you can see my front is 100 and rear is 300. Now let us see the delete operation. If I see the delete operation, I will check whether my front is null or not, because if my front is null, it indicates that my queue is empty and we cannot perform any deletion operation. So if front is not null, so in that case, I will create a temporary pointer and store the address of front in it. Store the address which is stored in front in the variable temp. Then I will display the data which I am going to delete, and we will check. If front equal to rear, this indicates that there is only one node in the queue, and if we delete this node, it will make both front and rear equal to null, because after deleting the only node which is present in the queue, my queue will become empty. So if front is not rear, it means there are many nodes in my queue. So in that case, I will store the address of next node in front. So my front will now start pointing to the next node, and then I will delete temp, which indicates that I will deallocate the memory which is stored, the address of which is stored in temp. So delete is an operator which is used to deallocate memory. Let us understand it pictorially. So you can see, if we look at the previous example, this was the previous example in which we inserted 3 nodes, and my front is 100 and rear is 300. You can see front 100 and rear 300. There are 3 nodes. And data is 1, 2 and 3, and these are the addresses. So now when I say node start temp is equal to front, temp will also contain 100 because the address stored in front is 100. Temp will also contain 100. Now both temp and front are now pointing to the first node. Now I will check the condition, is front equal to rear or not, because if front is rear, there is only one node. So in this case there are three nodes, so front is not rear. So out of this and this, only one statement will be executed. So as front is not rear, this will not be executed. This will be executed. Now this is what? Front equal to front arrow next. So if you see here, currently front is 100 and the next part of this address is 200. So you can see if front is 100, the next of this node contains 200. So now front will contain 200. You can see here, now front will contain 200 and rear will remain the same 300. And temp, which was pointing to the first node, we will say delete. When we will say delete temp, this node will be deleted from the memory. So this is how this works. Now let us do one more delete operation. Now in this case, now front is 200 and rear is 300. So when I again say node star temp is equal to front, so again temp will start pointing to this first node. As front has address 200, temp will also have address 200. So this is the present scenario. Now we will check whether front is rear or not. No, front is not rear. Front is 200 and rear is 300. So this condition is false. So this statement will be executed. Front is equal to front arrow next. We can see here front is at present 200. So 200 arrow next is 300. This is the next portion of this address. So front will become equal to 300. So you can see here, this is the structure of my queue now. Front is 300 and rear was earlier also pointing to 300 only. So this is my new structure. When I say delete temp, temp is still pointing to 200, the second node. So when I say delete temp, the node at this address will be deleted from the memory. So memory allocated to it will be deallocated. Now in the present scenario, both front and rear are 300. So when I say node star temp is equal to front, front will also contain 300. This is 300. So all of them, they are pointing to this node. So again I will check, is front equal to rear? Yes, front is equal to rear. Both of them are 300. So this is the only node, and the deletion of this node will make front equal to null and rear equal to null. So you can see both front and rear have become null and my queue is empty now. So you can see that currently both front and rear are done and my queue has become empty. So this is all for this video. I hope you have understood queue as a linked list. And if you like this video, kindly give thumbs up, and you can also subscribe to my YouTube channel. Thank you.